So I have the osmotic pressure equation over here to the right. You can see that this right here is what represents the actual pressure. And then this right here is molarity. So remember that unit is moles of solute over liters of solution. I'm reminding you which R to use because you can see that this looks a lot like that gas equation. So that could be your hint that it's 0.0821. Maybe, I don't know, seeing liters in the problem or ATM in another problem could also maybe be your hint. And then the temperature has to be in Kelvin. Don't forget that to get there, you add 273.15 to your Celsius. So the first question is actually just solving for osmotic pressure. And so this is equal to, and this is where my molarity would go. So molarity is moles per liter. I'm going to have to mess with the top part just a little bit to get my moles. 0.0821, and that's my liters ATM, mole, Kelvin, and then times my Celsius, which is 60.0 plus 273.15. So that's going to be turning out in Kelvin. I'm going to go back over here. So if I have 5 grams of glucose, I'm going to kind of zoom in here. So if I have 5.0 grams of glucose and I need to get it in moles because we're talking about molarity, all I need to do is use that molar mass, the 180.16 grams in a mole. And again, that's talking about glucose if you were wondering, into liters. So this should be a good setup for my problem. I'm just going to go ahead and put it all in my calculator all at once. I start doing 50 divided by, let me bring this down so you can see it. So 50 divided by 180.16 divided by 3.0, so that whole quantity times 0.0821 times parentheses, because I'm adding something, 60 plus 273.15. And that gives me that my osmotic pressure is 2.5. Notice that this had 2 sig figs, this had 2 sig figs. When you added these, though, these would have more than 2, so it's going to be going with the 2 sig figs. And if you aren't sure on your units, then my liters cancels here, my moles cancels there, my grams canceled there, and my Kelvin canceled there. So my unit is ATM, which makes sense because that is a pressure unit in the problem.